Hello everyone, welcome to my channel Prochem Academy. Now today I will discuss another chapter of class 10 ICSE, that is electrolysis. Now we are starting today electrolysis, and different topic we will discuss in different videos. Okay, now see what is actually this electrolysis. Now you can divide the word actually here, the electro and lysis. Okay, that means electro and lysis. Now you can think that this electro means, okay, flow of electrons or electric current. Okay, or electric current. Here the electro means the word flow of electrons or electric current, and here lysis means separating. Okay, so in the presence of electrons, flow of electrons or electric current, we are going to separate something. That is the meaning of this word electrolysis. Okay, now that means you think that here something electric current and some separation is there. Okay, now what is from what the idea is coming here, that we know about the metals. We know about the metals that iron, nickel, silver, gold, these are all the metals. Okay, and copper is also a metal. Now normally these metals are good conductor of the electric current. These metals are good conductor of the electric current. That means if you pass electric current through these metals, then they will conduct electricity. That means they will pass the electricity easily. So they are the good conductor of the electric current in solid state. So actually metals are good conductor of electric current in solid state. Okay, and these metals are called conductors. Okay, electric conductors, and these metals are called what? Conductors. Okay, now this, how these metals can conduct electricity. Okay, good conductors. Okay, how these metals can conduct electricity. Okay, by the movement of free electrons they can conduct electricity. Okay, say metals, and this is a metal. Say you take copper. Copper is a metal in solid state, so it has free electrons. This copper has free electrons. This kind of free electron it has. Now when you pass the electric current behind over this copper, then it will conduct electricity by the movement of the electrons. Okay, by the movement of electrons, metal, that is conductors will conduct electricity. Okay, conductors will conduct electricity by the movement of electrons. Okay, but the solid non-metals, okay, they are not good conductor of the electricity, or the non-metals are not good conductor of the electricity, so they are called non-conductors. Okay, so conductors are the solids, metals, which can conduct electricity by the movement of free electrons. And what is the direction of the electric current? Okay, the direction of the flow of electrons, okay, will be opposite to the flow of electric current. That means the direction on which or in which the electrons are moving, in that opposite direction of the movement of the electrons, the flow of current will be there. Okay, so the opposite direction of the flow of movement of electrons will be the direction of the electric current. Okay, so that is the direction of the electric current through a conductor. So what we have learned, that metals are good conductor of the electricity. That means if you pass the electric current over there, then it will conduct the electricity, that means electric current, and by the movement of electrons. And non-metals, nitrogen, oxygen, these are the non-metals and they cannot conduct electricity, so they are the non-conductors. Okay, so normally we are in a housing purpose we are using the copper metals, so they are good conductor of electricity. Okay, but if we take some substances, okay, apart from this, some chemical substances, in chemistry we are learning the electricity in chemistry, so there some substances will be there. Okay, so say we are taking a substance. Okay, that means if some substance can conduct electricity, some substance can conduct electricity, okay, they will be called as electrolyte. So actually the electrolysis topic will be only applicable for the substances, okay, not the conductors, not for the metals. Okay, say I am taking a beaker, or a apparatus, okay, and here I have taken sodium chloride. Now this sodium chloride can present in three different states, While I am taking the solid sodium chloride, okay, it is a substance. We can take lead bromide also, PbBr2, solid form. Now, if you pass electric current over this solid sodium chloride or solid lead bromide, it will unable to conduct electricity. That means solid sodium chloride and solid lead bromide are not good conductor of the electricity. They are actually non-conductors. Okay, while they are present in the solid form. Okay, now how will we pass this electric current over here? Okay, we have to make a apparatus to do the electrolysis process, and this process will be called as electrolysis process. What we will take, that we are taking sodium chloride or lead bromide you are taking. Okay, say lead bromide you have taken. Now solid, whenever we are taking solid lead bromide here, okay, now to do the electrolysis we need some other apparatus. Okay, we need a beaker or something like apparatus, and we need to take two plate of the metals, okay, or as one metal you can take, graphite you can take. Okay, two plate we have to take here, that means here only. Now these two plates will be called electrodes. These two plates, that means a plate of inert metals, okay, they will be called as electrode. Why they will call electrode? Because this when these plates will be joined with the external battery or external electric system. Okay, say this one is the external electric system. Okay, external electric system. Now external battery will have two poles, one is positive pole and another one is negative pole. Now if the positive pole of the battery is joining by a switch with this electrode, okay, the positive pole of the battery, if the joining with this one of the electrode, okay, the electrode with which the positive pole of the battery is connected, okay, its charge will be positive and it will be called as anode. Okay, the electrode which is joined to the positive terminal of the battery by wire or by a switch, that will be called as anode, and the electrode which is joined with by the negative pole of the battery is called cathode. So these two are the electrodes. So we need to make a apparatus which contains a glass apparatus like lead bromide. This is, we have taken a substance and we have taken anode and cathode. Now whenever you are taking solid lead bromide, and after putting here cathode and anode, after passing electric current, you will see if you merge your bulb here, okay, if any bulb is here, then after passing electric current here, you will see that this bulb is not glowing. That means this bulb is not glowing. Whatever you have taken cathode and anode and one substance you have taken, this bulb is not glowing. That means this solid lead bromide is unable to conduct electricity. That means this solid lead bromide is unable to conduct electricity. Okay, unable to conduct electricity. So they are not the good. They cannot conduct the electric current. Okay, but if you take here molten sodium chloride, that means the molten form of, sorry, not molten lead bromide you have taken, sodium chloride also you can take. So if you take molten lead bromide here, then molten means just the molten, but or aqueous lead bromide. Aqueous lead bromide means you have to take water here. So whatever you have done, that you have taken water here, okay, and in that you have added substance lead bromide. So you have got the aqueous solution of lead bromide. Now, if after that you have added, you have placed here two cathode and anode, and you are passing the electric current. In this case, you will see this bulb is glowing. That means here this can conduct electricity. Lead bromide can conduct electricity. Okay, in its aqueous state and molten state. So what I want to tell here, that if any substance, not any metal, if any substance in fused state or in molten state, what about the states? In fused state or in molten state or in gaseous state, aqueous state. Okay, after passing electric current, can conduct electricity. Okay, can conduct electricity. They will be called as not the conductor. They will be called as electrolyte. So, and this process will be called as electrolysis. Okay, whenever we are taking a substance which is in the molten state or in the fused state or in aqueous state, and after passing electric current, if they can conduct that electric current, okay, then those substances will be called as electrolyte and the process will be called as electrolysis. Okay, and what will happen here, that after passing this electric current, we will get some different product in this electrode. Okay, that means chemical change will be done here. That means you will see chemical changes going on here. What kind of chemical change? Here lead bromide in aqueous solution, okay, will dissociate to form Pb2 plus and 2 Br minus. Okay, now these are the ions. This one is called cation and this one is called anion. Okay, I am going to describe all the electrolysis process. That means the actual electrolysis process, what I can say. Okay, so I am going to try this one. Okay, so this lead bromide will dissociate to form cation and anion. Now, if you pass electricity, here in the solution we have cation and anion, Pb2 plus and Br minus. Now these are the charged species. So they will conduct the electricity. So in case of electrolysis process, in a substance which will conduct electricity, the cations and anions will conduct the electricity. In case of conductor, we have seen which will conduct electricity, that is free electrons. But for the substances which will in the solid state, in the gaseous state, or in the molten state or in aqueous state, they will conduct electricity by these cations and anions. Now, those substances which will form these cations and anions are called ionic substances. We know that means ionic compounds. So normally every ionic compounds are electrolyte. That means whenever you are taking an ionic compound, okay, and after passing electric current through the electrodes, you will see the cations and anions are forming, okay, and they will conduct the electricity. Okay, so this process is called electrolysis process, and the substances which can take part in this electrolysis process are called electrolyte. Okay, and the apparatus or the cell in which it is done actually is called voltmeter. is called voltmeter. Okay, it's called voltmeter. So this is the overall electrolysis process actually. Okay, now I am just telling some terms of this electrolysis process. That so what is the summary of this process? That we need a electrolyte. We need a electrolyte. Now, what is electrolyte? The substances which in molten state or fused state or in aqueous state, okay, can conduct electricity, and after conducting electricity, it will form different kind of product. Okay, or that is called the electrolyte. Okay, now electrolyte means, and those will be mostly ionic compounds. Mostly ionic compounds. That means it will form cation and anion. After forming cation and anion, it will conduct electricity in the molten state or aqueous state or in fused state. Okay. Now, understood. Now we can classify this electrolyte as strong electrolyte, or as weak electrolyte. Now for the strong electrolyte, those ionic compounds which will be strong electrolyte, they will completely dissociate in the aqueous solution. That means they will complete furnish ions. Okay, they will be called as strong electrolyte. That means sodium chloride. Sodium chloride is an ionic compound, so it will furnish positive ion and a negative ion. That positive ion will be called cation and the negative ion will be called anion. Now it will be completely dissociate. That's why sodium chloride is forming Na plus and Cl minus, and complete dissociation will be there. Complete dissociation, okay, will be called as strong electrolyte. Others are there, sodium hydroxide are there. Okay, so these are the strong electrolyte. Weak electrolyte, incomplete dissociation or partial dissociation will be there in aqueous solution. Okay, partial dissociation in aqueous solution. You can take acetic acid. Acetic acid is when it furnishes CH3C double minus ion and H plus ion. That means it is not fully dissociates, because these hydrogens will not dissociate again. Normally this is just giving H plus, and all acids are the electrolytes. Okay, we can take all the acids also. So this is the classification of the electrolyte: strong electrolyte and weak electrolyte. I think you have understood what is the electrolyte. Okay, we need to know about the electrolyte. Now we have to make a cell after taking a strong electrolyte or weak electrolyte, but they should be in molten state or fused state or in aqueous state. Mostly we are doing the electrolysis in the aqueous state. Okay, so a strong electrolyte or electrolyte we have taken. Okay, the cell where this electrolysis process is doing, that process is called voltmeter. So we have to take a voltmeter, and there we have to take electrolyte. Okay, means sodium hydroxide, potassium hydroxide, sodium chloride, lead bromide we have to take. Okay, now after that, in aqueous solution they will furnish the cations and anions. Okay, and if you pass electric current through cathode and anode, after that we will get a product. Okay, now what will happen? See, we know that say we are taking a lead bromide. Okay, so many things we are going to discuss, but not today, in different video. Okay, but today I am just telling the proper way to do the electrolysis. Okay, so lead bromide we will have in aqueous solution. In aqueous solution we have lead bromide, we have cathode and we have anode, and this is joined with the battery. Okay, this is joined with the battery. Now this lead bromide will furnish Pb2 plus and Br minus ion. That means this solution contains Pb2 plus ion and Br minus ion. Say this is anode, that means positive charge, and this is cathode, that means negative charge. Okay, Now we know that as anode is positive charge and cathode is negative charge, so actually cations are having positive charge. Okay, so these cations will go to the negatively charged electrons. Okay, cations will move towards negatively charged electrode. Why? Because cations are positively charged and cathodes are the negatively charged. That is cathode. Because both will be attracted to each other. Okay, so cations will move towards the cathode. Okay, cations will move towards the cathode. Now what will happen? As this cation like Pb2 plus is having less number of electrons, that means it is electron deficient species, that's why it is a positive charged. But this cathode is the density of the electron is higher here, because that's why it is negatively charged. Okay, so what will happen? It will try to make a neutral compound, neutral metal. Okay, so or neutral element actually. So this Pb2 plus will go towards this cathode. Okay, it will go towards this cathode and it will take up electrons, because it will try to make itself a neutral element. So Pb2 plus cation will go towards the cathode, that means negatively charged electrode, and will take equal number of electrons to neutralize the charge. That means 2 electrons will take up to form free lead. Okay, to form free lead, and this will deposit in the cathode. This will deposit in the cathode. Okay, that means Pb will deposit here. Okay, so by the definition I have told you that one compound we will get, or some new product we will get. Okay, some new substances we will get, that is the lead. We are getting lead here in the cathode. Now you see, in the cathode this reaction is going on. So this reaction is called cathode reaction. Okay, this reaction is called cathode reaction. So by the electrolysis process we are going to get a cathode reaction and we are going to get an anode reaction also. Now this process, lead 2 plus 2 electron to lead. In this process you can see that lead is gaining the electrons, that means lead is accepting the electrons. Now any process in which one element or one ion is accepting electrons, that process is nothing but the reduction. So here reduction is going on. So in cathode one reaction is going on, one process is going on, that is the reduction process. So what is the summary? That means cations will go to the cathode and it will take up electrons by the reduction process and it will form a neutral element. Similarly anions. Okay, anions will go to the anode. Anions means this Br minus. Now it is electron rich species. Now this cathode, this anode is electron deficient. Okay, so this one will go to the cathode, anode. Br minus will go to anode and it will give electron to the anode. It will release electron to the anode. Now the same charge of this anode, the electron will be released. Here the charge is -1, that means 1 electron will be released to the anode. Okay, so here -E. Okay, and it will form Br. Now there are so many Br minus ions are there. I have written also 2 Br minus here. So many Br minus ions are there. You know this is ionic compound. Another Br minus ion will go to anode and will release another electron to form Br. Now these two Br will join to form bromine gas and it will release from the anode. Now this process is called oxidation. This process, that means release of electron. The process in which the electron is released, that process is called oxidation. So in anode we will get oxidation, in cathode there will be reduction. Okay, in anode there will be oxidation and in cathode there will be reduction. Now this reaction, that means this is the cathode reaction, this is anode reaction. Okay, and what is the electrolyte dissociation reaction? When you are taking an electrolyte here PbBr2, it is forming Pb2 plus and 2 Br minus. This reaction is called electrolytic dissociation reaction. Okay, and this Pb2 plus will go into the cathode, and it is going to the anode. Now this is the normal electrolysis of PbBr2. Okay, like this process you can do for other substances, but this process, that means this cathode and anode reaction, may change. Okay, may change on the basis of the electrode what you are taking. Okay, so this electrolysis process depends on the electrolyte, that means electrode what you are taking. If you are taking graphite electrode, the electrolysis process may differ. If you are taking platinum electrode, electrolysis process may differ. If you are taking normal, what you are taking, the electrolyte, if that metal you are taking as a electrolysis process may differ. Okay, so actually this is the common electrolysis process. So in next class, in next video, I will discuss another electrolysis process. So what is this summary of this class? That we have done the discussion about the electrolysis, normal, how it is doing. Okay, we have to take a voltmeter. In that voltmeter, one glass apparatus will be there. You have to take a electrolyte, which will be ionic compound in fused state or molten state or in gas or in aqueous state. That will furnish cations and anions. Now after passing electric current, cations will move towards the cathode. After reduction, it will form a solid compound, solid species or solid substance. It will deposit in the cathode, and anions will move towards the anode, and it can after oxidation, that means after release of electron, it can form a neutral element, and that can be formed by a gaseous element. Okay, that can form a gaseous element. So this is the process. Now my question is that why this solid sodium chloride are not conducting electricity? We have seen that solid copper can conduct electricity, but why solid sodium chloride cannot, or solid ionic compounds cannot conduct electricity? Why the okay, somehow it is stopped the video. Okay, just so let me say that why sodium chloride, solid form of sodium chloride or solid form of lead bromide does not conduct electricity. Because in the solid case, solid form, there is we know that the sodium chloride is ionic compound. Sodium chloride is ionic compound. So it consists of Na plus and Cl minus ion. It consists of Na plus and Cl minus ion. Now here in this Na plus and Cl minus ion, we have learned in this topic that this Na plus and Cl minus ion will have a strong electrolytic attraction force. This one we have learned in previous class also, in previous videos, that strong electrostatic attraction force. Okay, now to do the electrolysis process, okay, to undergo the electrolysis process, these ions should be separate. Okay, that means should be separate. But here in the solid form, we don't have any kind of effect that can separate this electrolytic attraction force, because this is very strong electrostatic attraction force. So in the solid form, these ions will not be separate, so that will not conduct electricity. Also for lead bromide also. But in aqueous state, what will happen? In aqueous state, there will be polar water molecule. That means water is a polar molecule. So in case of, just I am giving the example of lead bromide, that though there is a strong electrolytic attraction force between lead and bromide ions in aqueous form, but this oxygen of the water molecule is partially negatively charged, you know. So there will be attraction between this negative pole of water, that is oxygen, and the positive lead 2 plus ion. Okay, so it will make a separation. Again, there is attraction between the positive pole of water, that is hydrogen, and between the lead bromide ion. Okay, so it will make this separation. Okay, so that lead 2 plus ion or bromide minus Br minus ion will be separate, and that will conduct electricity. Same way for chlorine also, chloride also. So that is how this solid sodium chloride and solid lead bromide, solid ionic compounds will not conduct electricity, but aqueous form will conduct electricity. Aqueous state will conduct electricity. Okay, so some other electrolysis process. This is the normal introduction part of the electrolysis. In other classes, in other video classes, I will discuss other electrolysis topics. Okay, so Please watch this video, and if you have any doubt regarding this video, regarding this topic, you can ask me over comment box, okay, so that I can make other videos. So if you like this video, then do like, comment and subscribe my channel. Thank you.